objects that are thrown up or falling right gravity, we want to check their motion this time around. We will solve them. When the acceleration due to gravity is 10, acceleration due to gravity G is equal to 10 meters per second squared. So when something is thrown up, it works, gravity works against it to come down. When it's falling down, the gravity helps it to fall down. We're going to examine all this. Let's look at the question now. The question says, a stone is thrown upward. A stone is thrown upward with a velocity of 14 meters per second. How high does it reach, and how long does it take to get to that height? If something is thrown up, by the time it gets to the highest point, you say how high it gets to the highest point, it must want to come down, and for it to come down, it will stop. So when it stops, the velocity at that height is equal to 0. So if we use the first equation, the velocity at that height, this is the first equation, second equation, third equation. If we use the first equation, the velocity at that height will be 0. So v will be 0, because for it to come down, it must stop. And when an object stops, velocity is 0. So if an object is thrown up, just like the question said, a stone is thrown upward with a velocity of what? So initial velocity was 14 meters per second. With the initial velocity of 14 meters per second, how high does it reach? And what's the time? If we want to get the time, we can use this first equation, which means 0, the highest, the velocity it got at this highest point, but it has to stop to come down, is equal to the initial velocity, which the question says is 14 meters per second. 14. Then it is thrown up, so it's working against gravity. Minus. That's why it minus, because it's working against gravity. 10 is essentially due to gravity times time. So with this we can get the time. So with this will be time will now be equal to 14 over 10. 14 over 10 is the time we used, which in this case is 1.4, which is equal to 1.4 seconds. So that's the time it's used to get the highest point when the stone is thrown up. So for me to get the distance, I can use any of the equation, either the first or the second. Because if I use the second now, I will see that u is already, when it was going up, the u is 14 already, and time is already, I already know the time. Acceleration is g, that is 10, then the time, simple. I don't have final velocity there. If I use the second one, v squared is 0, because that's the highest velocity. This is 14, this is 10, and s is what I'm looking for, the distance travel. So any of these can solve the problem. So if I use this one, I have that s is equal to, that is 14 times time. That's 14, the initial velocity, times 1.4 minus half times 10 t squared. Oh, the 10 is given now. T is given, that times 1.4 squared. So time is given, because we have known the time now. That means, that's why we calculate the time first. That means the distance s, the distance s gave us 9.8 meters. If we do what I have on the board, 9.8. If I work out this, I got 9.8 meters. That's the distance. That's the highest height it will get to before you want to come down. A stone is, the question says, I repeat the question. A stone is thrown upward with a velocity of 14 meters per second. How high does it reach? How high does it reach? And how long does it take to get to that height? At the highest height, velocity is 0. That's one thing. You now check the equations. Equation 1, equation 2, equation 3, equations of motion. Which one will help you solve the problem? The one that will help you have only the unknown you are looking for. Use that one and solve the problem. So we use the first one to get the time. We use the second one to get the distance, the highest height. You can also use the third one if you wish. So that is it. That's solved. Thank you very much.